All right, let's talk about something huge in the programming world. Object-oriented programming, OOP. We're going to break this whole thing down, but not like a textbook. We're going to make it super simple, super intuitive, so you can stop seeing code as just a bunch of lines and start seeing it as a way to build actual things.
So, you know that feeling, right? You're coding along and suddenly you realize you're just typing the same stuff over and over again. You've got all these variables and they all look kind of the same, and your whole project just starts to feel like a total mess. Trust me, it's a super common problem. We've all been there.
I mean, just look at this. Imagine you're making a simple system for a school. To keep track of 100 students, you could end up with this nightmare. A name and an age for student 1, another name and age for student 2, all the way to 100. It's a disaster to read, and can you imagine trying to update it? No way! There has to be a better way to do this.
And of course there is. The solution, though, isn't just some clever little trick. It's a complete mindset shift. It's about getting away from just writing abstract instructions and starting to think about the real-world things your code is supposed to be dealing with.
And that's the absolute heart of object-oriented programming. Instead of juggling a million loose bits of data and functions, OOP lets us take everything related to one concept, like a student or a car, and bundle it all together into one clean, tidy package. Your program starts to actually look like the real world it's supposed to represent.
Let's make this even simpler. Think about toys. You know that a car toy is a totally different thing from a robot toy, which is different from a doll, right? A car is red and it rolls. A robot is silver and it walks. What if your code could understand things with that same clarity? What if it knew what a car is, all on its own?
So how do we actually do this? How do we teach our code about these things? Well, it all comes down to two incredibly important ideas. The best way to think about it is like you're an architect. You don't just show up and start throwing up walls, right? First, you got to have a plan, a blueprint, and only then do you build the real thing.
And here they are. This is the whole game, right here. In the world of OOP, the blueprint is called a class, and the actual real thing you build from that blueprint, that's called an object. If you can just get your head around these two words, you've pretty much cracked the code of OOP.
So let's dig into that first one, the class. A class is just the blueprint. That's it. It's the design on paper. Our class for a car would say, okay, every car needs to have a color and it needs to be able to accelerate. But just writing that down, it doesn't create a car. It's just the idea of a car.
And this is where the magic happens, the object. This is when you take that blueprint off the table and you actually build something from it. You take your student class, your plan, and you create a real student in your program, like Ali. Ali is an object. He's a real instance of a student. And the best part is, from that one blueprint, you can create Ali and Sarah and 100 other student objects, all perfectly made from the same plan. Okay, so we've got our object. We've made Ali. But what is he exactly? What's actually inside this little digital person we've created? Let's pop the hood and take a look.
You know, it turns out to be pretty simple. Every single object you ever create, whether it's a student, a car, or a space alien, is really just made of two fundamental parts. These two things define everything about it, what it is and what it can do.
And here they are. On one side, you have attributes. Think of these as the details, the facts, the data about the object. And on the other side, you have methods. These are the actions, the behaviors, the things it can do. So, attributes are like the nouns, and methods are the verbs, what it is versus what it does.
So for our student object, Ali, what are his attributes? Easy. His name is Ali, his age is 15, his grade is 10. These are just the facts that describe him, the data that makes this particular student unique.
And what about his methods? What can he do? Well, he can study, and he can attend class. These are basically just functions. But here's the key. They belong to the object. They're the actions that a student, and only a student, can perform.
Okay, so we've got blueprints and real things, details and actions. I know it sounds a little formal, maybe a little complicated. So you got to be asking, why? Why bother with all this? What's the real payoff for thinking like an architect?
Yeah, let's just cut right to it. Why is this whole OOP approach better than that jumbled mess of code we saw at the very beginning? Is it really worth the effort?
Oh, it is so worth it. The advantages are just massive. You get reusability. You write that blueprint once and you can make 1,000 objects from it. You get modularity.
Everything is in its own neat little box, so you can change one thing without breaking everything else. You get clarity. Your code starts to read like a story about actual things. And the big one, scalability. This is how you build huge, complex programs without losing your mind.
So really, this is the takeaway. You go from the chaos on the left, 100 disconnected variables that are a nightmare to manage, to the beautiful, clean organization on the right. One single blueprint and 100 perfectly organized, self-contained objects. It's the difference between a garage floor covered in random parts and a fleet of perfectly assembled cars.
Now, I know this all might still sound a little abstract, but you're gonna be shocked when you see how simple this actually looks in code. Let's take a quick peek at how you'd create your very first blueprint and your very first object. Seriously, this is it. Step 1. With one simple line, class, car, you're just telling the computer, hey, pay attention, I'm about to define the blueprint for what a car is. That's all it takes to get started. And step 2 is just as easy. You create a variable, myCar, and you tell it to build a new thing using your car blueprint. And bam! Just like that, you've done it. MyCar is no longer just a plan, it's a real, actual car object that exists inside your program.
So let's do a super fast recap. Here's our little cheat sheet. OOP is just about making your code think in terms of real-life things. A class is the blueprint. An object is the real thing you make from it. Attributes are the details about the object, and methods are the things it can do. That's really all there is to it.
I absolutely love this quote because it just nails the whole mindset. If you remember one thing, remember this. Be a toy maker. You don't build every single toy from scratch. No, you design the master plan once, and then you use that plan to crank out hundreds of unique toys without ever repeating the hard work. That's the power of OOP.
And really, that's the big idea here. When you truly get OOP, you kind of graduate. You stop being someone who just writes down a list of instructions for the computer to follow. You become an architect. You become a designer. You start building entire worlds filled with things that know how to interact with each other. And honestly, that's when programming gets really fun.